This is MA 104, Section 3.4, numbers 61 through 70. We're asked to find the standard form of the equation for the quadratic function whose graph is shown. We can start with the vertex form of the function, which is y equals a times the quantity x minus h squared plus k. By knowing both the vertex, which is 1, negative 4, and one additional point on the graph, either one of these, we can use negative 1, 4, or 3, 4, we have enough information to plug into this equation to find a. We need to solve for a. Again, it doesn't matter if we choose this point or this point as x and y. The whole point of any equation is that any ordered pair on the graph of the equation will work when you plug them in for x and y. But h and k are specific. H and k need to be the vertex. Let's use this point 3, 4. We'll focus on that point. So if I plug the 4 in for y, that gives me 4 equals, I need to find a. X comes from that point, so I'll have 3 minus the x-coordinate of the vertex, which is 1, quantity squared, plus k, so that's plus a negative 4 or minus 4. And again, that minus 4 comes from the vertex. This is enough information then to solve for a and to find what a is. Doing so gives me 4 equals a times 3 minus 1 is 2 squared minus 4. If I square that 2, I have 4 equals a times 4 minus 4. I'll add the 4 to both sides, which gives me 8. I'll bring it up here. Adding the 4 to both sides gives me 8 equals a times 4. Divide both sides by 4, and I'm left with 2 equals a. Now that I know that a is 2, I can rewrite that vertex form of the function, but instead of just the a by itself, I can plug in my value of 2 now. So that gives me y equals 2 times the quantity x minus the x-coordinate of the vertex, so that will be x minus 1, quantity squared, and then I still have that minus 4 to represent the y-coordinate of the vertex. The 2 is what we calculated. X and y are left as x and y because they represent any point on the graph, and then the negative 1 or the minus 1, that's the opposite of the x-coordinate of the vertex, and the minus 4 comes from the y-coordinate directly. This is the vertex form of the equation. We are asked for the standard form, which means that we have to multiply out this quantity. Please remember that in order of operations, exponents comes before multiplication. So I'll be squaring the x minus 1 before I multiply the 2. This gives me y equals x minus 1 quantity squared. Just to review, x minus 1 quantity squared means x minus 1 times x minus 1. If I do FOIL, or if I do that idea of repeated distribution, I distribute the x, then I distribute the minus 1. That gives me x squared minus 2x plus 1. So when I come back to my equation, I have 2 times, when I squared that x minus 1, I got the x squared minus 2x plus 1, and I still have the minus 4. Now I can distribute the 2, which gives me y equals 2x squared minus 4x plus 2, and I still have the minus 4. My final step then, since I want this as a function, instead of y, I will put f of x equals 2x squared minus 4x. The plus 2 minus 4 combines to minus 2. So here is the function that represents this graph written in standard form. The same idea here. I have the vertex, which is negative 1, 4, and then I need one additional point on the graph. It doesn't matter which one I use. I'll use the 1, 2. I want to start off with vertex form, which is y equals a times the quantity x minus h squared plus k. I don't know a, but I have enough information to solve for a. That additional point, that 1, 2, allows me to plug the 2 in for y, equals, I'm trying to solve for a. X comes from that point, so I'll have 1 minus the x-coordinate of the vertex, so minus a negative 1, which is the same as plus 1. So I have 1 plus 1 quantity squared plus 4. The 4 comes from the y-coordinate of the vertex. Again, I have to follow my order of operations. So in parentheses, I have 1 plus 1, which is 2. And I'm going to be squaring that. I still have the plus 4. 2 squared is 4. So this gives me 2 equals a times 4 plus 4. I'll minus this 4 from both sides to get negative 2 equals a times 4. When I divide both sides by 4, I find that a is negative 1/2. Knowing that allows me to plug that value of negative 1/2 into vertex form. So I have y equals negative 1/2 times the quantity x minus the x-coordinate of the vertex. So x minus a negative 1, which is the same as x plus 1, quantity squared, plus k, or plus the y-coordinate of the vertex, which is plus 4. We expected the a to be negative because the parabola opens downward, so we did expect that that leading number, that 1/2, to be negative. Again, order of operations says I have to square this quantity first, so I will multiply that out to get y. I'll bring the negative 1/2. X plus 1 quantity squared, just like in the last slide, was x squared plus 2x plus 1, and I still have the plus 4. I will distribute the negative 1/2, so I have y equals negative 1/2 x squared minus 1/2 times 2 is just 1, so minus 1x, or minus x, minus 1/2. Minus 1/2 times 1 is minus 1/2, and I still have the plus 4. Finally, to write this in functional notation, I have f of x equals negative 1/2 x squared minus x, and then the minus 1/2 plus 4 is plus 3 1/2. This is the function written in standard form. I'm asked to find the equation of a quadratic function whose graph contains the vertex of negative 4, 12 and a y-intercept of 4. Well, we know that the y-intercept is any point where x is 0, so a y-intercept of 4 translates to being a point of 0, 4 on the graph of the function. I can start just like the last two problems in this section with that vertex form, which is y equals a times the quantity x minus h squared plus k. I know that the h and the k represent the x and y coordinate of the vertex, and the 0, 4 represents the x and the y that I can fill into this equation. My y value is 4. I'm trying to calculate a. X comes from the ordered pair 0, 4, so that would be the x coordinate there is 0, minus the x coordinate of the vertex. So minus the negative 4 is the same as plus 4, quantity squared, plus k would be plus 12. That's the y coordinate of the vertex. Following my order of operations, I do what's in parentheses first. So I have 4 equals a times 4 squared plus 12. I'll be squaring that 4. So 4 equals a times 16 plus 12. Minus that 12 from both sides. And I'm left with negative 8 equals a times 16. Divide both sides by 16. And I am left with a equals negative 1/2. I know my value of a now, so now to write the equation of the function, I can just say that f of x is equal to negative 1/2 times the quantity x minus the x coordinate of the vertex. So x minus the negative 4 is just x plus 4, quantity squared, plus k, or plus the y coordinate of the vertex, so plus 12. It doesn't specify whether we need to have that equation in standard form or vertex form, so this is vertex form and that is fine. The same idea here, we're given the vertex and we're given an additional point on the graph and we're asked to find the equation. We'll start with vertex form, which is y equals a times the quantity x minus h squared plus k. I can use the negative 5 and the negative 25 for the h and k, and I can use the negative 2 and the 20 for the x and the y. Plugging all that in will allow me to solve for a. So this gives me 20 equals a times the quantity, negative 2 minus a negative 5 is the same as negative 2 plus 5 squared, minus 25. So I have 20 equals a times negative 2 plus 5 is 3. So that's times 3 squared minus 25. I can add my 25 to both sides. So this leaves me with 45 equals a times 3 squared. 3 squared is 9, so I have 45 equals a times 9. Divide both sides by 9, and I find that a is 5. So writing the equation of my function, I have f of x equals 5, now that I know that a is 5, times the quantity x minus a negative 5, that's the x-coordinate of the vertex. X minus a negative 5 is the same as x plus 5, quantity squared, and then the k as it is would be a minus 25. Again, it doesn't specify what form I have to write this in, so vertex form is fine.